name is Kristina Tomšiu. I work also here in the AI and data team in Prague, but my main focus is natural language processing, or NLP. And in my talk today, I would like to introduce you to a very cool NLP topic, which is semantic search. Semantic search, that's basically a smarter search that uses meaning and context rather than looking simply at keywords. And if you have a search that actually understands what you're looking for, this can really help you in going through hundreds of pages or thousands of documents in a much less painful way and save you lots of time and effort. For this to work, though, you need a system that would understand the meaning of words that you're using. And that is usually done using word embeddings. Word embeddings are sets of numbers that represent the meaning of word based on the different contexts in which it appears. So if we illustrate on the example of a word dog here, it would get scored along multiple dimensions, such as how much alive it is, how much of an animal it is, and so on. Across all these dimensions, you would get positioning of this word into semantic space. And each word would get a unique position in there. This is a little bit complex to imagine, so let's simplify. We can reduce the dimensions to just 2D and show in this picture how such a space would look like. So for example, you can see that the words that are more similar to each other, such as dog and cat, would get close to each other. And words that are not so much related in meaning, such as dog and Prague, would get further apart. What's very nice is that this semantic space also keeps the relationships between words. So the distance and direction between the word puppy and dog would be very similar to the distance and direction between the word kitten and cat. And the same would go for Prague to Czechia versus Berlin to Germany. And since all this is represented as numbers, we can quantify it. We can quantify how similar two words or two documents are to each other. And this is really the basis for semantic search. So how would that work? Well, you ask a question and you get the right answer, as simple as that. If you want to understand it a bit deeper, let's just look at the individual steps of the pipeline. So first, you would need to prepare your documents, what we call knowledge base. That's all the input documents in which you want to look for your information. For simpler documents, you would parse them basically into the different sections, different topics that they cover, based on the titles and so on. For more complex documents, which would be like PDFs with lots of graphics and visual elements, you would use computer vision to split them into sections. Once you have this structured data, you can actually index it in some way. That means embed it into this, using one of these embeddings that I was just talking about. And then you're ready to start asking questions. So you can ask your question or pose a query. This gets embedded into the very same semantic space as the documents you had before. And then across hundreds of pages and thousands of documents, you would find a section that's the most similar to the question that you just asked. And then, depending on the exact implementation that you have, you can either just get the reference to the exact part of the documents, or you can put, for example, question answering model on top that would already summarize a tailored answer to the information that you were looking for. And this can be done across languages, so no matter whether you ask your question in Czech or English, you will get to the very same results. Also, you can work with different input documents. We saw an example of a PDF before, but you can also input a complex Excel table. In fact, we tested many different kinds of documents, be it CVs, be it very long ESG reports, complex internal policies, or documents from legal and regulatory. Talking about legal, you can now hear more about AI laws in the EU from my colleague Katarina.